Hello everyone, welcome back to another video. In today's video, we're going to talk about solving mathematical problems that include series and parallel circuits. We'll be starting with a series circuit, a basic series circuit. Then we will see another type of an example for a series circuit, and lastly we'll go for a parallel circuit. And in the next video that I'll be making, we'll be talking more about if the parallel circuits have different values given and you have to find those quantities in a different approach. So each of the videos will be solving different types of problems. Okay, so let us start with a very simple and basic series circuit. Before starting with a series circuit, we have to know the properties of a series circuit. That is, in series circuit, the current through all points in the circuit remains the same. So it doesn't really matter if I place the ammeter at this point, or over here. Eventually, the current in the circuit will be the same at all places. So that is one thing we have to know. The other thing we have to know is the total EMF, that is the total voltage, which is 25 volt in this case, is divided between each of the component. Here we have two resistors, R1 and R2. The 25 volt will be divided between them. The total of V1 and V2 should always give 25 volt. So we will try to find out how much is V1, how much is V2, how much is the total current, and then see how we can use them. Alright, so the first step is find the total resistance in a series circuit. How do we find the total resistance in a series circuit? We simply add the two resistors. Since there are only two resistors here, we'll just simply add them. 50 plus 25 gives us 75 ohms. Once we know the total resistance, we know the total voltage, we can find the total current in the circuit, which is total voltage divided by total resistance. 25 divided by 75 giving us 1/3 ampere, right? That is the total current that I'm getting in the circuit. Very good, we have done with the total current, very simple. Once we are done with the total current, we can find individual voltages. I again repeat, the current through each resistor remains the same in a series circuit. It's not that one of them will get less current, the other one will get more current. In all the resistors, if there were more resistors, all of them would have got the same current flowing through them. So when I'm trying to find V1 using the formula V equals to I into R, what I'm doing is I'm just taking the current 1/3 into the resistance R150 and finding the voltage V1. Similarly, when I'm finding the voltage V2, I'm again putting the same formula. R2 is replaced with 25, voltage comes 8.33 volt. Pretty simple, right? Now, in the next example, what we will see is we have been given with the value of V1, but not with the EMF. In the previous example, the EMF was given, the total current we had to find, but here the EMF is not given, the current is not given, but one of the voltage is given. Now, how do we use this to find the total current and everything? So what we can do is we can find the current flowing through this resistor only. Why? Because we know the voltage of this resistor, we know the resistance of this resistor. So what we do is we use these values to find the current flowing through R1 only. So that's what we did here. Current through R1 is V1 by R1, the voltage of this resistor divided by the resistance of this resistor. The 0.5 ampere current I'm getting is the value of current flowing through R1. And in series circuit, as we know, the current flowing through R1 should be same as R2 and the same throughout the circuit. So we can very easily say that if I can find the current through R1, I can also find the current through R2 because it's the same current in series circuit. In all the places we have the same current. Now if you have to find the value of V2, you can do it easily. You know the current flowing through R2 is 0.5 ampere and you know the resistance of R2 is 50. So V equals to I into R. You get the voltage to be 25 volt. Once you have got the voltage V2, you can find the EMF of the circuit also. How? Just add these two voltages up. We know we add the potential differences in a series circuit. It should always give us the EMF of the circuit. So this example shows even if you're given the voltage of any one of the component of a resistor or a lamp and its resistance, you can use these two values to find the total current in the circuit. So this is something you have to remember, that in a series circuit, you always don't need the total voltage or the total resistance. You can have individual voltage of one component and its resistance that will allow you to find the current throughout the circuit. Next up, we have a parallel circuit here. So here we have a parallel circuit with two branches. Each of this is called a branch, and there is one resistor in branch 1, but there are two resistors in branch 2. So how do we solve this? So before we start for parallel, we have to know the property of parallel circuit, that in parallel circuit, the current coming out of the battery is shared between each branch. So if the current is, let's say, 1 ampere, this 1 ampere will be divided between branch 1 and branch 2, right? So here the total current is not given, but what is given is the current in each branch is given, which is 1/3 ampere and 2/3 ampere. So I know the total current here is divided between I1 and I2. So why don't I just add them up? I1 and I2, that gives me the total current. So if you add 1/3 plus 2/3, you can get the total current 1 ampere very easily without any problem, right? So I can get the total current. I don't know the EMF of the circuit, that is not given to me. How do I find the EMF? So first let us see how do I find the total resistance of this circuit. So okay, when you have two resistors in a branch in a parallel circuit, if you have two resistors, that is more than one, not exactly two, any resistors more than one, what you first do is you add them up, because R2 and R3, they are in series, they are in the same line, so you cannot treat them as parallel resistors. Okay, so R2 and R3, we first add them up and find the total resistance of branch 2. So branch 2, 20 plus 10 gives me a total resistance of 30 ohms. Once I know the total resistance of branch 2, now I can use my formula for finding the resistance in parallel circuit, which is 1/RT is equals to 1/60 from here, 1/R1 plus 1/R2. R2 is the total resistance of branch 2. So our formula 1/R1 plus 1/R2, the R2 here represents the total resistance in branch 2, not any individual value. If someone does it like this, that 1/RT is equals to 1/60 plus 1/20 plus 1/10, this is completely wrong, because these two resistors 20 and 10 are not in parallel. So first you add them up, you find the total resistance 30 ohms, and then use it to find the resistance in parallel circuit. Once you find it out, you will find the total resistance coming to be 20 ohms. 1/RT is 20 ohms, so RT is 20, right? Now we go here to find the values, the value of V1, the value of V2 and V3. All right, so let's say first find out the value of V1, 1/3, because we know the current flowing through this resistor is 1/3 ampere, and you multiply it with 60, it gives you 20 volt. All right, next we go and find the value of V2 and V3. Let us just skip this part for now, we'll come back to this later. We'll find V2 and V3. Again, we know the current in branch 2 is 2/3 ampere. So for V2, what you do is 2/3 into 20, because V2 is across this resistor. You can find V2. Then you find V3, again 2/3 into 10, which gives you 6.67 volt. So now you have V2, you have V3, you have V1, and you already had the value of I1 and I2. All of these are given to you, right? Now, there is another property of a parallel circuit we must know. The other property is, in a parallel circuit, the voltage across each branch should remain the same. That is, if the first branch has a total voltage of 20 volt, the second branch should also have a total voltage of 20 volt, and the EMF should also be 20 volt. That is, in each branch, the total voltage should be 20. So we found the first branch to have a voltage of 20 volt, and from there we can write V1 should be equal to EMF. Whatever the value of the branch 1 voltage is, if it's 20, EMF should also be 20. And also branch 2 should have a total voltage of 20 volt. So let's check out if branch 2 has a total voltage of 20 or not. Let's come back to this, values of V2 and V3. So V2 we got 13.33, V3 we got 6.67. Let's add them up. I hope you have your calculator in your hands. this should again give you 20 volts. So which is showing me that each branch has the same voltage, and using that concept we can find out the EMF of the circuit and the individual voltages. The total current we already found out in the very beginning of the math. We did it. We found it out as 1 ampere, right? In the very beginning here it was 1 ampere. We did it here. But there is another way you can find the total current. So we'll discuss that also. I hope it's clear up to here. Anyone has any doubts, you can go through the video again. There is another way you can find the total current using Ohm's law. We know the formula current equals to V by R. So when you're finding the total current, you take the total EMF divided by the total resistance. So now we have already found out the EMF to be 20 volt. We found the total resistance beforehand, which was here 20 ohms. So if you use this method also, still you get the current to be 1 ampere. So either of the process is correct. You can go through the Ohm's law process or just simply add them up if you have both the currents. Okay, I hope the video helped you out. I hope you can now solve the series and parallel circuits maths much more easily. We'll come up with more videos. We will be talking about if the circuits are combined together, series and parallel. How do we solve that? How do we sort out the steps? And I hope the videos will help you out. Thank you for watching, everyone.